What are waves? Lesson 2.
Overview. Chapter 14 Energy. Energy exists in several forms and is the ability to cause change. In Lesson 1, we saw what different types of energy there are and what forms they take. In this lesson, we'll look at what waves are, and in the third lesson, we'll see how light behaves. Chapter 15 is all about heat and electricity. Thermal energy is transferred as heat, and Chapter 16 is about forces and motions. Applying forces can start, stop, and change motion.
Vocabulary. Number 1, wave. A wave is a disturbance that carries energy through matter or space. Number 2, crest. The highest point on a wave. Number 3, trough. The lowest point on a wave. And the illustration shows you that the crest and trough are at opposite points of a wave.
Number 4, wavelength. The distance from the middle of the crest of one wave to the middle of the crest of the next wave, as you can see pictured in the top right. Number 5, amplitude. The distance in a wave from the resting position to the top of the crest or the bottom of the trough, again as you can see pictured to the right. Number 6, frequency. The number of times per second that the wave cycles. Number 7, electromagnetic spectrum. All of the energy waves that travel at the speed of light in a vacuum. Radio, infrared, visible, ultraviolet, X-rays, and gamma rays.
The electromagnetic spectrum, that was a long, complicated definition. This illustration shows you all of the waves that are included in the electromagnetic spectrum.
Waves. What is a wave? When we think of the word wave, we usually picture someone moving a hand back and forth to say hello, or maybe we think of a curling wall of water moving in from the ocean to crash on the beach, as pictured to the right. In physics, a wave is a disturbance that travels through space and matter, transferring energy from one place to another. When studying waves, it's important to remember that they transfer energy, not matter. There are lots of waves all around us in everyday life. Sound is a type of wave that moves through matter and then vibrates our eardrums so we can hear. Light is a special kind of wave that is made up of photons. You can drop a rock into a pond and see waves form in the water. We even use waves, microwaves, to cook our food really fast.
Think and respond. Explain the relationship between waves and energy. Read the question, think about it, then type a response.
Waves. All waves can be categorized as either mechanical or electromagnetic. Mechanical waves are waves that require a medium. This means that they have to have some sort of matter to travel through. These waves travel when molecules in the medium collide or hit with each other, passing on energy. One example of a mechanical wave is sound. Sound can travel through air, water, or solids, but it can't travel through a vacuum. It needs the medium to help it travel. Other examples include water waves, seismic waves, and waves traveling through a spring, as you can see in the top right, with the particle motion and energy transport. Electromagnetic waves are waves that can travel through a vacuum, which is an empty space. They don't need a medium or matter. They travel through electrical and magnetic fields that are generated by charged particles. Examples of electromagnetic waves include light, microwaves, radio waves, and X-rays. You can see on the bottom left another example of some electromagnetic waves. It reads the electromagnetic spectrum includes all kinds of light, the kind that we can see, which is visible, and many kinds that we cannot see.
Think and respond. What is the major difference between mechanical waves and electromagnetic waves? Read the question, think about it, then type a response.
Waves. What is a wavelength? Do you see two small words within the word wavelength? You probably recognize wave and length. How do these words help us understand the meaning of wavelength? The amplitude of a wave is a measure of the displacement of the wave from its rest position. The amplitude is shown on the graph below. You can see there's a straight line in the middle of the wave And from that point up to the top of the crest is the amplitude, or from that point down to the bottom of the trough could also be considered the amplitude. Amplitude is generally calculated by looking on a graph of a wave and measuring the height of the wave from the resting position. The amplitude is a measure of the strength or intensity of the wave as characterized by the distance from the resting position to the top of the crest. For example, when looking at a sound wave, the amplitude will measure the loudness of the sound. The energy of the wave also varies in direct proportion to the amplitude of the wave.
Think and respond. What is a difference between amplitude and wavelength? What is a similarity? Read the question, think about it, then type a response.
Pause this film and watch the one that you see on the screen. It'll be right below the video you're watching. When you're done, come back to the instructional video.